Welcome to my workshop. Today we're gonna work on the build plate, drill out the holes mostly. I know this could have been done on the CNC, but honestly, as the operation is so simple, it's way faster to just do it manually on the drill press. So let's do that. Of course, before drilling, we will center punch each hole. Basically like that. First we will drill out a 4mm pilot hole, and then we will do the countersinking with the big 9mm bit. just checked, and the countersink is not quite deep enough yet. So I go like another millimeter like this. Now it fits. Now to do the last two. Today, a very big part to machine. The biggest part, in fact, I've ever machined. I'm kind of excited. So this is basically going to be the base plate for my printer. And I've laid out all the markings. Now I just need to machine it. But before doing anything else, I will first have to punch some holes. Gonna do the rest off camera. Got all holes done, at least the punching. Now comes the drilling. This part length 650 millimeters and it's 432 millimeters wide. finished all 4mm pilot holes. At least all of them could be made on the drill press. Those I will do by hand. Now 6mm. This video is sponsored by PCBWay. Do you need some metal parts for your next project? Check out their services. Do you need some metal parts? Maybe PCBWay can help you out. They offer a large selection of services. From CNC machining, over sheet metal fabrication, up to 3D printing services like SLM. If you need some metal parts machined, there's a wide selection of materials like aluminum, stainless steel, brass, copper, titanium and many more are available. They also offer a large selection of 3D printable materials like nylon, TPU, polycarbonate and even PEEK, or SLM printed aluminum, stainless steel or even titanium. I decided to redo the counterbore because I didn't like the results of doing them by hand. This part won't fit on the drill press, so I'm doing it manually with a file. Originally I wanted to cut in slots here. I feel like it's already enough extra space for the cables. This is the aftermath. Feels like a metal workshop. These nice chips. I'm basically finished. This hole is filed out. It's basically the same diameter. Of course it's not as nice as the other ones. And the only major mistake was this here. and it's on the underside. So it doesn't really matter. It's one day later and apparently I did make a mistake. So when I originally measured this and laid out the markings, I used this side. In CAD this was the top side. And then when I was downstairs and I had like that happened, for example, I decided this was going to be the bottom side. But then this here does not line up anymore. So either I have to remachine this hole next to there and have an extra hole, or I'll just use it like this. Also, one negative is the counter bore that I had for these screws, where I wanted to use M4 sunken head screws. They're on the wrong side now. It's still gonna work, but it's not gonna look as nice. But I also don't wanna pay another 120 euros for one of these alu plates again. My plan is to just cover up the bottom anyways with insulation, so I guess in the final product you won't see this little mistake. Now the really interesting bit begins. The gantry has to be lifted into the printer. For that I take off both top extrusions, then it can basically slide in from the top. But this is the first time the gantry goes in with all the belts and motors and whatnot. Before it was just a skeleton. So the last time this was assembled it was just a frame basically. So this is how the electronics bay looks now. It's basically finished. The wiring is not quite finished yet, but mostly. And I want to turn it on, just to see if it releases the magic smoke or if it's wired up correctly. Okay, now let's see. We got lights. So far no smoke. I've also plugged in the Raspberry Pi. Seems like that's good as well. This is going to be an overview of this printer and its systems. So this printer is called Anduin, like the Great River from Tolkien, from Lord of the Rings. So why did I build this cross gantry printer? Because I've kind of hit the limits of my Voron 2.4. And yes, I could run monolith gantry, for example, 4 motors and whatnot. But for now I want to focus on this machine. And it's a cross gantry, so we can have way more motor power. We have way shorter belt paths. And in general we should get way better input shaping results. In total there are 3 lighting zones. The first zone is up here for the gantry. The second lighting zone is for the bed. And the third lighting zone is the electronics bay, which is not really necessary, but I had some lighting left over. As you can see, I'm running active motor cooling with SLM printed parts from PCBWay on all 8 motors for the gantry, so we can push really high currents for some high accelerations. This is the tensioning system for the belts. They are basically identical. One negative is that the back one is really hard to reach. You don't have to disassemble the printer, but you have to move over one of the krakens. And yes, there are 2 krakens now. At first I only ran 1 kraken with 2 motors per driver, and it worked. As far as I know, it's not the ideal setup. And with the second kraken I can control how much current each motor gets more precisely. Now this is how the electronics bay looks right now. It's still a little bit messy. Still have to clean it up. There will also be a big knock-door fan, like a 200mm knock-door fan, blowing on both krakens. Initially I wanted to run an SSD, and I still want to run an SSD on the Pi, but I had some trouble setting it up. So for now we're just running an SD card. Maybe if you watched some of my other videos, the gantry looks familiar, and that's because this is literally the same beam that I use on my Voron 2.4, just a little shrunken down. Just a little shorter. Actually I designed this one first, and then I adapted it to my 2.4. So this has been in the works for like 2 years right now. Almost. The Z system has 3 independent belts, so we can do 3-point leveling. In the future I plan on putting a beacon in here instead of running a clicky probe, but for now the clicky probe is way cheaper and I already have experience with it. These are 10mm GT2 Gates belts, and with this setup we should be able to run really high tension. The Z system also uses 10mm belts and has a kinematic mount. It's not really necessary, but I don't know. I like engineering, so it was a fun little challenge. And yes, I know one could make this way more efficiently by not using this extra aluminum structure and just having the bed rest on each of the joiners directly. But oh well. Eventually I will also run clipper screen and have this touch screen up and running. But right now I've basically just focused on the mechanical aspect of the printer. The toolhead will get a slight redesign, so I can run a volcano nozzle. Right now I'm just running the Goliath with a CHT 0.4 nozzle, but not a volcano one. Then I will also be able to run the full crown cooler. Right now, as you can see, it's like a cut-off duct, like 3/4 of a crown. Eventually I plan on machining way better motor mounts, but I'm just using the stock Taicho printed ones right now. because they work. And as I'm not pushing crazy currents, the motors don't get over 100 Celsius right now, so it's fine. But I plan on cranking the currents way higher. And for that I will probably need motor mounts out of metal. But it's gonna be a fun challenge to machine them myself. Like I machined all other parts on here, except for these SLM printed heatsinks. I cannot manufacture them, but PCB I can. So all of the panels on this printer, except for the electronics bay, are 5mm polycarbonate panels, because they're stronger and they're more heat resistant than the 3mm acrylic panels that I'm using on my 2.4. Now you might ask yourself why I'm not actually running water cooling, like the VZBot for example. It's because I actually want to keep the chamber hot. Like I want to keep the heat that the motors produce inside of the chamber. So we can print like high-end engineering filaments fast. Because they tend to warp if the chamber is not hot enough. So in a way I think that with water cooling you're kind of wasting that heat potential. That's why I've decided on active cooling with air. There's also no risk of a water leak from the vibrations or whatever. This is basically a top-down view.